I actually made a, well, we're using a PowerPoint, so nope, that's the wrong button.
Sharing screen is enabled.
Okay, perfect. Let's get it going. So I kind of cheated and just used our bootcamp thing because it works the exact same way. And my computer is going to take a hot second to load. So yes, we are totally doing a manufacturing bootcamp right now. Joke's on you guys. Next 2 hours is actually just manufacturing. So about me, I'm Steph, Chide, all that fun stuff. I think everyone knows who I am here. So who we are and what we do is kind of what the important part is we're the people who make the parts that get designed. And this means that we are prototyping with any new designs that like mechanical or electrical come up with, or messing around with 3D printers and filaments, even though we've kind of ironed out what filaments we wanted to use. And the fun thing about this team that has really changed with COVID is the team is actually very hands-on. And in the past, you got to learn the full assembly of the arm in detail. And the team in the past used to be more independent work and really was a more flexible schedule. And in the past, we operated 2 locations, the Shapiro Design Lab and the BME Fab Lab. And now, thanks to Max, we actually have a really cool partnership with a print farm, which people are going to get to go see from, I think, the majority of the team if you're interested in assembly. So some projects that we did was, due to COVID, we couldn't meet in person. So manufacturing had the very fun time of trying to adapt to virtual work and learn how to do it at the same time for a team that really was not designed to be, online. So it was a very comprehensive training, or very comprehensive theoretical training for the fall semester. And then in the winter semester, we did a development of basic QA/QC standards to start being used and improved by assembly team, when they're ready. And this was, as I said, during the winter semester. And in the future, now that COVID has kind of decided to chill out and everyone's vaccinated, we're finally able to transition to hands-on training and learn how to repair these printers that we have, because the great thing about 3D printers is that they break all the time. And along with this, we'll be kind of streamlining our printing processes, which is a constant thing that always has to be done. And this can include optimizing settings for print farm printers, ideal part orientation. And then, another constant thing we're doing is receiving feedback on documentation and updating it as needed, especially, as we're starting to create more partnerships with other groups. And we get feedback from those groups. And, as always, as has been, part of manufacturing since the beginning of its conception, was rapid prototyping and printing deliverable arms. So yeah, and a little bit about our process, again, this is not so much right now, but now that we're finally able to change or get back into it, it's like coming again. Is a print list gets created of parts needed by mechanical or electrical or whoever. Someone on the team picks a part to review. This involves looking for certain flaws and problems with the model. If the flaw is found, projecting the part and telling whoever designed it that they need to go fix it. And this can also mean smoothing seams that to make it look nice. I do not have a palm with me, but if you look at the model of the palm, there's like a really obvious seam. So you can tell what was printed by manufacturing and what wasn't, because we actually go in and smooth all of those seams that are created. And then once it's all printed, you check the part for errors that may have happened. And if another print finishes, you also take care of it. And then store the print, repeat the process, clean it up, all of that fun stuff. I hope most people know what 3D printing is, but I can just go over it quickly. It's known as additive manufacturing, hence our name, manufacturing. And it prints layer by layer to create 3D objects. It's actually a really cheap and quick way to manufacture items, and it's really beneficial for rapid prototyping, like we ideally like to do when it's not COVID season. There are multiple types of 3D printing, but we used fused deposition modeling, which is called FDM. It's the most common and the easiest form of 3D printing. And there are many different softwares and printers out there, but they all function mostly the same. But this is also, if you look through our documentation, why we don't have set instructions of, okay, this is how you turn on your printer. This is how you use the software, because everyone uses different software, which is great. And we don't really want to be like, okay, you have to use Kira, or you have to use Simplify 3D, or you have to use a Pulse printer, because there's a big versatile range. And of course, now the dog wants it. I don't really think we need to learn how a 3D printer works because it's pretty straightforward. And these are the printers we use. Uh, you know, these three right here, we're not using so much because, again, Shapiro Design Lab is closed and it's great. But the Creality CR10S are at the print farm. The Prusa i3 MK3 is at the design lab. MatterHacker Pulse is also at the design lab. But Daniel has a fun one named the Chadbot that is a pretty big workhorse and is really fun to mess around with. And then my favorite, the one that always has a special place in my heart, is the PrinterBot Simple Metal. So yeah. And then some 3D printing jargon so that people understand what we're talking about when we're discussing. Filament is this fun stuff right here. It's what the plastic is called that is used in 3D printing. It gets melted down and is extruded into a really small stream to print. There are many different types of plastics and composites used in 3D printing. Again, this is boot camp, so we're not going to talk about them later, but mainly what we use is PLA, which is a corn-based plastic. So it's biodegradable, which is great, safe for the environment, yay. We use that for prototyping, and then for our actual print, deliverable prints, we use either PETG, which is a weaker version of PCTG, which is in the same family, but it has a polycarb infill that makes it stronger, and I'm getting eyeballed by a dog. The spool is what the filament is kept on. Generally, it mounts on or near the printer as the filament is fed into the machine. Printers each have their unique way of mounting spools. STLs for our fun programming stuff. STL is what the files get exported as from CAD. All these edits are made to this type of file, and it's the most common file used for slicers. So, if you go download something off the Thingiverse or, get something sent to you from Mechanical, it's going to be an STL. But you also can have fun times of people send you the wrong thing and then you can't read or your programs can't read the file they sent you because it's the wrong file. G-code is what the slicer generates from the STL, and it's basically a set of coordinates that the printer reads line by line, and it's not meant for humans to read. So, I barely know how to understand it, and most people don't. It just is not meant to be, so that's fine. And then CAD. I think everyone knows what CAD is. It stands for computer aided design. This is what Mechanical uses when they design what we print. My team really doesn't do much with CAD except for maybe occasionally downloading parts from Mechanical, and then Mechanical uses Fusion 360. And then slicer and slicing software is the big software that manufacturing uses. It is where the 3D file, STL, is converted for a 3D printer to understand it. This is where settings and part orientations are finalized. There are many softwares, but they all function similarly. And the program we've mainly been using in the past year and a half, 2 years is Kira, because it really is a very versatile thing and it's free, which is always great. We have other programs that we use, but they are not available to us, on our personal devices. And then, yeah, any questions? I'm going to quickly go off screen just because my dog is wanting in. Sorry. Wait, come on.
Yeah. Could you explain a little bit more in detail for newer members how you work with the other sub-teams, such as electrical and mechanical?
Sure thing. Here, one sec. I'm going to stop share so people can see my lovely face. We get in contact, so we'll have, again, this is when it's not COVID and, we have much more easy access to 3D printers. But either Mechanical will be, designing a new part that they want tested to make sure it can be 3D printed and it's sized properly and, all the components fit, or electrical needs a test bench or something, again, just needs to be designed. They reach out to us and say, hey, we need this 3D printed. And then again, it goes through that process of, okay, the print list is created, or, if it's one thing, it's assigned to someone and, they print it and yippee-ki-yay, it's done. And then it can just get handed off. But, no smiling. But yeah, it's really just that there's communication between teams. Generally, it's a team lead will reach out to me, and then I can negotiate or delegate tasks as needed. Or if it's a larger print list, members can take whatever part they have time for and get it started at whatever facility is available to them. So just lots of communication between teams. It's not really that fancy, but or occasionally too, we'll have a print list sent to us as Mechanical did last year when they were doing a bunch of fun stuff of editing printer or editing files before we were doing Michael's previous build. So yeah, anything else?
Sure, yeah. Any questions about generally what their process looks like, what they do in the day-to-day, or anything else that anyone has any questions about?
How are meetings like oriented in manufacturing?
So obviously right now it is online, or well, in the past it was online, and the way that it works really has been the same, even if it's online or in person, not including the training sessions, was because our team really is more independent work based. It's meeting up. Okay, here's the announcements from team wide stuff. Here's some stuff we need to be prepping for the next couple of weeks. And then kind of getting updates from when we were doing KIC, getting updates from all the subgroups that were doing their stuff. Or, as people are printing stuff, just saying, okay, how is stuff looking? And, how are parts coming out? Is there anything we need to focus on? Is there a printer that's broken? So it's a lot of just, updating each other, and obviously, delegating tasks if those need to be done, stuff like that. Anything else?
Some people, you mentioned filaments earlier, but some people might also not know the difference between things like PETG versus PCTG, PLA, and ABS. So why do we select the filaments that we do? And what's the kind of price point of those filaments that we use?
Sure thing. So as I mentioned earlier, PLA is like what we do for prototyping. It is a really basic filament. It's one that like literally everyone uses. It's not very strong, so we're not going to be wanting to print like deliverable arms. So that means it breaks easily, and it's pretty brittle. But the reason we select that is, as I mentioned earlier, it's biodegradable. So it's good for the environment. It's not having to be melted down to be reused. You can compost it. Which fun little side story is if you want to mess with people at the library, we'd always go dump our PLA prints in the compost bin, which you can do. But we use that because it's environmentally safe. It's safer, it's non-toxic. So if it's printing, you don't have to worry about ventilation or anything while being around it, compared to ABS, which is another really common, cheap plastic. I should mention both of these are around $20 a kilogram, and sorry, clock is going off. But they're about $20 a kilogram. So, you get a spool, which weighs a kilo, and again, $20, pretty cheap. But ABS requires really specific ventilation because it has toxic fumes that comes off it. And it requires a much more specific set of standards to print. Like you have to have a really controlled environment for it to be in, compared to PLA is a lot more straightforward. PETG is a lot more available, and it can range, I think, about $30 or $40 a kilo. And we ideally don't use it very often because it's not as strong, but it's stronger than PLA for sure. It's probably about the same level of strength as ABS. But it's just a lot more widely available than PCTG, which is specifically made by like a very few companies. And that ranges about $40 to $50 a kilo. But the reason we really like that is because it's approved for biocompatibility. So, you can make prostheses out of it. And the FDA says, okay, that's cool, that's okay. But it also is really that it's strong, but it's also not rigid. So it can bend a little bit. Obviously, you're not going to be able to bend the arm, but it can take a beating much more than, the other filaments that we use. And it also keeps lightweight compared to ABS, which is a much more heavier plastic. But the main thing is that it's that, nice intersection of lightweight, flexible, and strong. And that is because it has a polycarb infill into it. So it's PETG or PETG with polycarb in it. And the reason we have all these fun acronyms is you have these long chemical names that nobody knows or wants to try to pronounce. So that's why we refer to them by that. But yeah, those are the the three ones that we mainly use. And just to answer the question again, ABS is just toxic, so you try not to use it. And I think actually most places at U of M do not allow ABS printing because of that toxicity. But yeah. Anything else, or we're good to move on?
Yeah, I would like to have to where we give each team the full 20 minutes. So if anyone else has any questions, feel free.
In the meantime, if we want some motivation, there's my dog passed out in the middle of the floor. Nope, that's not the dog. There's the dog passed out in the middle of the floor.
I guess an additional question would be, what kind of tasks are current members involved in, I guess, going forward?
Sure thing. So as mentioned, we weren't able to meet in person to do training. So the month of June is really dedicated to getting all of our new members finally able to 3D print, because that is like our main thing. So that's really what June is going to be dedicated to, is finally being able to meet in person. Obviously still social distance and all that fun stuff for the most part. But actually getting people used to using the 3D printers, able to learn how to use or set up the palm, the forearm, all the different prints, or all the different parts of the arm, and actually able to manufacture it themselves, instead of us having Daniel, myself, and Max being the ones that are mostly making things. So it's a little late in the year, but we're finally able to start training. Yay!
Fantastic. Any last questions in the remainder of the minute? Not, I guess we can ask, when are your meetings, Steph? Some members were wanting to know for each team's meeting. So since you're starting it off, when are manufacturing meetings?
Sure thing. So our training will actually start this coming Thursday at 6 p.m. The first one is to train on Kira, our print setting, like our printing software, and that will be online. So yeah, Thursday 6 p.m. Eastern Standard Time or Daylight Savings Time, whatever time setting we're on. But yeah, and then the rest of June will be in-person meetings at the print farm. So you can contact me if you want to come learn how to 3D print, and if you need a ride, I can provide one. Otherwise, yeah.
Cool. Well, thank you for manufacturing. Let's go on ahead to outreach. So, Sienna and Yusra, if you want to take the show.
Yeah, sure. Welcome to everyone who's new. We're really glad to have you, and we're excited to share, I guess, everything about MNP in these next 2 hours. So as far as outreach, Sienna and I are the co-leads for outreach, and we've pretty much divided things into internal and external. Present. Yes, Daniel, there are meetings. We're getting into them. All right.
Yeah, so here's our MMP outreach progress update. Like Yusra said, I'm Sienna, I'm the co-lead. And Yusra, you can take it away.
I'm excited. Okay. So this is how we pretty much think that other sub-teams see outreach. In the last, I think it was the team leads poll or Google form, a lot of you guys said that outreach was very productive sub-team. So I thought this image kind of demonstrated that. And while it is true, sometimes it does feel like this, not all the time. Here we go. This is how outreach sees outreach. It's a lot of sending emails. It's a lot of waiting for responses from emails. And personally, I have felt this way. I know Sienna has felt this way as well, because we did a lot of work in expansion. And in the beginning, that was just basically sending emails to whoever we could find who would take those emails. So this is how it sometimes feels. Sometimes it gets a little bit more like this. So the reality is not many people answer your emails, but when they do, it is really exciting. And then sometimes it gets to this point. Now, this is a joke, but it is semi-true to the sentiment that can happen. Thankfully, it's not the majority of the time, but sometimes it feels like this. Thankfully, it is more than just emails. So we do things like finding the patients who get to receive the arms that everyone gets to build. We meet with people in prosthetic clinics, like the Department of Orthotics and Prosthetics. We organize seminars, socials, fundraisers. We apply for funding. We maintain social media. And we develop relationships with other universities and nonprofit organizations around the world. So it's pretty intense, pretty exciting.
So here's a breakdown of outreach for people who aren't familiar. So there are 3 sub-teams. Yusra and I are both on the expansion team along with Vincent. Expansion deals mostly with national and international communication, and we represent Blue Bionics to external entities. And then we have the professional development sub-team. They organize speaker seminars, they work on resume building and business skills. And then also there's the public relations team, which deals with MMP marketing, social media, and local patient and hospital outreach.
The next difference we wanted to talk about, and you may have heard these terms thrown around in meetings before, and so we thought it'd be important to talk about the difference. We are Michigan Neuroprosthetics, and that's what we've always been. And in the beginning of last fall, I think we were having discussions about this new name, and a lot of members got confused, like, oh, are we changing our name? What's going on? Essentially, what we did is we created a larger umbrella organization called Blue Bionics. And there are some technicalities between what kinds of organizations these are. So Blue Bionics is a VSO, whereas Michigan Neuroprosthetics is an SSO. And the main difference is that Michigan Neuroprosthetics has a faculty advisor. Why did we create Blue Bionics? Good question. It gives us the freedom to create sister organizations and distribution centers, both in the US and maybe even outside of the US. And then we obviously still think Michigan Neuroprosthetics is totally important to have. And one of those reasons, a big reason, is that we have access to the university's insurance policy in case anything goes wrong. So a little bit about why we have 2 organizations and what the difference is.
Okay, so to go into the national expansion team's projects, one thing that we've been working on recently is organizing a sister organization development with University of Arizona. So they started working on their first build last semester. That's on pause for the summer. They were having some technical difficulties with the build, but we're still working with them. They have connections to a prosthetic clinic in Mexico, but we haven't made any patient contacts there yet. So yeah, like we said, like it is slow moving, but we're still working with them. And then additional university outreach. We really encourage all of you guys to reach out to friends at other universities and to let us know what their contacts are, because Yusra and I have created templates for reaching out to these people and basically asking if they'd like to be involved in setting up a sister organization or distribution center. And so both of those, like the templates and the contact spreadsheet, are in the MMP drive. If you're not on the MMP drive, then I guess Slack message me or Yusra or pretty much anyone, and they can add you and you can add contacts there. And then there's national internal expansion goals. So these are things we're planning to do during the summer and in the upcoming year. So we're working on new member application and fall recruitment improvements. We're probably going to be restructuring a bit of like the interview process and things like that, and also working on formatting the outreach boot camp. In terms of internal affairs, we want to organize more team building and social events. So like I mentioned at the last all hands meeting, working on social events and also more formal events. And then fundraising and sponsorship packet advancements. and working with the financial director to apply for grants for the club. And yeah, also one of our main goals is just to help new members understand more of what's going on in other sub teams and understand like the printing process and things like that, so that they can feel more included in like all hands meetings, know what's going on, and feel more connected to the other parts of the club.
All right, so I'll take most of the time talking about international expansion because that's where a lot of the confusion might be. Right now, we're working with an organization called the Syrian American Medical Society, abbreviated as SAMS. So essentially, SAMS is a global medical relief organization that's working on the front lines of crisis relief in Syria and in the neighboring countries. Blue Bionics has come to an agreement with them that we want to donate 3 prostheses to refugee teenagers in Turkey who experienced traumatic amputations in the Syrian genocide. So if you want to learn more about SAMS, they're a really incredible organization. They're kind of like Doctors Without Borders, if you're familiar, but some of their like achievements include 91 medical missions, which is essentially where volunteers from the US or other countries all group together and go on trips as a group to provide medical relief. They also have built facilities. They have helped so many people, provided surgeries, all of that. So really awesome organization. You can click on this link. We'll probably send the slideshow in Slack or something. So if you are passionate about this kind of a thing and you know a part of the world that needs prosthetics or you want to explore that, we highly recommend you join Expansion. It's a really new part of the org, but we're really excited with where it can take us. So here's some information. I know some of the team leads and probably many members are curious about the kind of statistics and what's going on in Syria and what's the need and where are these, amputations coming from, what's causing them. There was a recent study published in March of this year that kind of identified the causes, talked about the levels of amputation rates, and all of the details. And this is also linked if you want to take a look. Essentially, the most important parts were that if you take a look, we work with patients who have transradial amputations, which means below the elbow. And so there are about 26 of the total 363 amputations that were studied. 26 of them were transradial. But on top of that, there were also patients who had double amputations. That means an amputation on both arm or multiple limbs. So you can see there's also 2 per group down here. So essentially there's a pretty big number of transradial amputations that are going on and people who need prosthetics. And a lot of the times it's, not something that people can afford. And as we know, it's very expensive. And this is kind of the perfect opportunity for MNP to help in. All right. Some details about the updates with SAMS is that we received a $700 grant from CSG last March to fund the supplies for the 3 builds. The beneficiaries are currently being finalized by SAMS. And from our end, we sent the measurement template and the legal forms back on May 9th. There's been some slow communication. As I mentioned earlier, you can think back to the memes. We've got to get through it though, so it'll be fine. It's just a lot of patience. So we're still waiting to hear back from them on some more details about selecting patients, and we'll be working on builds coming soon. So kind of shout out to next week. We're doing a workshop that goes through like all of the aspects of the build. And if you get involved in that, you'll be really prepared to help with the building process in the future. Going forward, you might be wondering, okay, so we're going to build these arms and we're going to send them, then what? We don't usually just send prosthetics and then wish everyone good luck and say goodbye. Like we usually work with our patients long-term. So once we build these arms and send them, we're planning to train clinicians in Turkey to figure out how to use these and figure out how to teach the patient to use them as well. So there'll be some kind of a training involved. Additionally, we'll be creating resources for the patient and family about how to use the prosthetic, how to maintain it, things to do, things not to do. And on top of that, we'll be devising some questionnaires to get feedback from the patients in regular intervals. Okay, there's a little bit of information on the slide, so I thought we'd go bullet by bullet. So what I just shared with you is kind of the highlight reel of what goes on in expansion. There's also a lot of developing relationships behind the scenes in order to make this successful. So SAMS has indicated interest in working together in the future to offer prostheses inside Syria because, as I showed you earlier, those numbers were from inside Turkey mainly. So that completely excludes the need inside Syria where there's so many more people in need of prosthetics. So we want to figure out a way that makes our impact more sustainable. So after these 3 builds, what are we going to do, right? That's something that we get to plan. So one way of doing so is training SAM's staff to print and assemble the arms themselves. So there are 2 options we've discussed in the past. One option is to find a university partner in the region who can supply the 3D printers and help us help SAMS, essentially. One of those universities that SAMS mentioned in the last meeting was Gaziantep University. They have 3D printers, but we have not yet heard what kind of 3D printers, and we'll probably get that vetted later on. The other option is to have a separate entity work with us, and we're currently having communications with that entity, still trying to figure out if that's going to work, but that'll take time as well. Another aspect of expansion that I've worked on in the past semester is talking to students at University of Rochester who kind of worked in the same field. They met with us in May, I believe, and shared their experiences about offering prostheses that were 3D printed to people in Lebanon in 2018. They're willing to advise us, and it's really great that we have them on board, I guess, to kind of guide us through the process and be there to help if any issues arise. So they gave us some advice in our last meeting, kind of similar to what you see here. They gave us advice about 3D printing, kind of warned us about some things that might not go as we plan in the future, of course, because right now we're just building the 3 prosthetics to donate. Another really important aspect is making sure that we respect patient priorities, which according to these people, they shared that there's a really high priority on aesthetic design of the prosthesis. So this could develop into kind of making it as human-like as possible. So one way we can do that is spray paint the color to match their skin. We're currently looking at ways to do that. We could potentially look into custom spray paints, but we're still looking at potential solutions to kind of cater to that desire. All right, here's a map just to get yourself situated if you're interested. The areas in blue are where the study was taken that I showed you guys. And then the area in red is where SAMS wants to expand to. Again, if you have questions, feel free to message me. I'd be happy to talk to you about this in further depth.
So going off of our international development, we're going back into the professional development sub-team. They recently hosted a successful speaker event with the Associate Professor of Neurological Surgery and the Director of the Neuromuscular Lab. And so their upcoming goals and initiatives are to continue to plan more speaker seminars for everyone and to also plan professional workshops. And Yusra and I also have made it a goal for that team to develop informative materials for new members for fall recruitment, which, like I said earlier, will focus on educating new members into other parts of MMP.
All right, we're going to have Anthony tell us about public relations. He is our website developer. Go ahead.
My name is Anthony Zhang. I'm I guess part of the public relations team. So just like what outreach is, we reach out to people through social media and then through patients, hospitals, and schools. Some things we've done the past year was reach out to school districts. Sadly, none of them replied back, but that's what we did. We also restarted our social media. We have a new Instagram now, and then we also have a new LinkedIn. Hopefully you send those links out to the various teams so you can give us a follow on both LinkedIn and Instagram. And then we also have this member of the week concept for Instagram. And it would be very nice if, some people submit a headshot and filled out the little Google form we have so we can feature you next year in the fall. Because it would be nice to have a hefty reserve of posts we can fall back onto. And then currently we're working on website improvements. Currently it's down due to some technical difficulties, but we're working on creating like a tier list of active members and alum. And yeah, that's basically us.
Yeah, we'll definitely share this link. If you go on the presentation, and we'll send this whole presentation afterwards as well, you will find the link to the LinkedIn as well as Instagram. And you can even just type Blue Bionics into LinkedIn and you'll find it quite easily. So
I'm putting it into the chat right now.
perfect.
And follow our Instagram.
Yes, and even
Please,
nominate
please.
people to be shown on the Instagram and you think they've contributed a lot to the org. That'd be another way, because I know some people might feel a little uncomfortable. And then one other thing is, if you don't want your name on the website, feel free to reach out. We totally respect anyone's privacy if they don't want that, but we hope to use it as an incentive to encourage members to actually be active, and we'll have some details on what that means in the fall. All right, so these are kind of our miscellaneous goals. Sienna mentioned these earlier. One new thing is we want to have Blue Bionics merch next winter. So that's going to be exciting, as well as we hope to plan a winter formal or gala or something more formal to highlight the achievements of everyone in MNP. So we're really excited. I'm seeing there are things in the chat, I'm sorry. Yeah, okay. Any questions, comments, or feedback?
Could you talk a little bit more about like the grant procedures?
Yes, that will be part of the workshop next week. Essentially, there are multiple ways we can apply for grants. So one of those is the College of Engineering as a separate grant process from CSG, Student Organization Funding Committee. In either case, there is a Google form you have to fill out, and there are certain things that can and can't be funded. Usually, if you can provide a list of expenses of materials that you didn't necessarily have to buy. For example, if you bought like a $1,000 camera and you could have just rented one from the university, they're not going to fund that. They're very realistic and accepting. So we'll talk more about that next week. Any other questions?
You guys mentioned you were working with the University of Arizona and then possibly SAMS in the future to kind of like have them start printing arms. I was just wondering if we've had any universities or groups of people like to date have successfully printed an arm.
Good question. So University of Arizona is our first sister organization, and they did have trouble with their 3D printers on their university, but because the timing of everything was kind of off, they had to pause because they went back home and all of that. So not yet, but hopefully in the future, fingers crossed. And that's why documentation is super important. So please make sure to clean that documentation up, because it will be very, very useful in the future. And documentation is basically everything that we document about our process if you're not part of MNP. So it's the instruction manual essentially.
Sweet. If and no one has any further questions, I guess we can move on to electrical. And thank you, Outreach.
Thank you. Hello, everybody. We're going to talk a little bit boring stuff, you know, just hardware stuff.
Sell yourself short.
Yeah, so welcome. Today, I'd like to share what the electrical hardware team does, as well as what electrical hardware is. The table of content, just the things that we're going to go through. Unlike the other sub teams, we won't go into like much detail towards how each individual component work, because those we do have boot camps for that, and those boot camps usually take like a month. So I can't possibly cram them into 20 minutes. So I apologize for that. However, if you're more interested towards the electrical components that we use, potentially the algorithm, we do have some resources in the team that allows you to understand more about our system. However, I would like to talk about in general how our arm works so you can get a feel for it. Here you can see is a test bench that we've created years ago. It's very jank. We're not doing this anymore, but at least it shows how the system works. Our system is being, okay, let's see where to start here. So first, the system is to receive a signal from a sensor. The sensor used here is a myoelectric sensor that detects electrical signals existence in the muscles when you flex your muscles. Those signals will be transferred all the way towards this microcontroller here. The controllers we use are all Arduino, using the Arduino IDE. It's very robust. We like them. And it's good for other people to do whatever edits they want to create their own systems as well. After receiving the signals from the malware sensor, this malware sensor will tell us when do we want to flex our arms. Knowing that signal, it then sends a control signal towards the two servos. And these servo motors are what allows the hand to open and to close. Two motors allow for more flexibility and dexterity within the design. In the past, we also have a one motor design, just fully open, fully closed. So these are the types of things that electrical is focusing on. It's about just, connecting everything together. It's about making the connection between the human and the machine, right? So how do we translate something being generated from the human body to something that is not really part of their body, but still make it feel as if it is theirs, right? That's the largest challenge and the largest motivation towards electrical hardware. Our sub-team deals with many hardware components. I've already mentioned a few. We used an Arduino controller. We obviously have to deal with the battery, actuators, sensors, also deal with some, user interface is not a component, but we deal with LED lights. Hopefully in the future, we'll deal with voice recognition modules. We'll deal with Bluetooth. We'll deal with touchscreens. Exciting, exciting stuff. We are probably, and correct me if I'm wrong, Max, the most expensive sub team in the club. I mean, I think just the electrical component. So our arm is what, $200? With all the electric components, what, like almost $100? So yeah, we all the other sub teams get pushed aside when looking at the budget towards the electrical hardware.
About it. Don't worry about it. We like spending money.
We like spending.
So much. I'm not even joking. Like seriously, everyone spend money and research things. We like doing things more than we like not doing things. So don't even worry about it.
Mm-hmm. In electrical hardware, our tasks are sort of divided into two subsections. One is focusing on the functionality of the system. Functional tasks, they deal with system control. They deal with steady signal acquisition, as well as desirable actuation schemes. In terms of user interface, we deal with more like the human part. So how does a person use the arm? How would the system indicate that it's low on power, or you have actually detected a signal from the person? We also are playing around with some aesthetic stuffs, and this is a collaboration between electrical hardware and mechanical team. We're attempting to create some very, very cool aesthetics, and I believe Charlie and Grant, you guys will talk more about that later. This is a very, very hands-on team. Our goal is, as Max said, we're just doing research and trying to make those things only existing in research papers to actually something usable. We see a lot of potential in the research that we do, and this is again, we're doing our own research, right? And yeah, as mentioned before, we do a ton of collab with other sub teams. Steph has mentioned we work with manufacturing team a lot. We work with mechanical team, and most recently, we're working heavily with interface team in order to design better sensors, which Rini will discuss further. So instead of going into like what each component does, today the presentation will be mostly focusing towards our current task and what we're doing. And hopefully you might be interested and have a few questions. So the first thing right off the bat is a dial control PCB for right arms. The people in charge of this project is Jan, Darvi, and Shweta. They're in the Slack. Feel free to contact them. They'll be happy to guide you through. But the problem we're currently facing is that we have only designed a circuit board that fits for a left arm prosthesis. Now, this might sound kind of dumb, because why wouldn't you create an arm, like a controller circuit board for both left and right arms? The reason why we're doing this is because we want to maximize the space being used in the arm, and it's already pretty crammed in there. So in order to use up the most of the space, we need to create separate circuit boards for different designs. And yeah, so we've only been working with left arm prostheses because we've been working with Michael, but like after talking with SAMS, we see that a lot of recipients, they're looking for right-sided prostheses. So the goal is to create right-sided prostheses PCB. Functionality includes 2 servos, wow, okay, I just did it. Okay, it's 2 servos, 1 sensor. I will edit that. The muscle sensor is connected through a 3-pin JST connector, and it is applicable to any kind of sensor that they want. We're also going to include a heat sensor for detecting board temperature as a way of safety. We have LEDs as our user interface, and then this board is also dial control and voice recognition compatible. Basically, it allows the system to change its states when need be. It allows the hands to do different functions based on the different states. In order to determine what state the system is, we have a potentiometer dial, the dial that you might see on a radio, and you just change the knob and it changes the state. Versus voice rec, less hands-on, you can just say the command and the system will go to whatever state you want it to be. Current status, minor. I don't know why I said minor, probably because there's some minor bugs that we need to fix. After those bugs are fixed, which should be this week, we're going to assemble and test the actual PCB starting June. And we need to talk with the software members to incorporate the heat detection part of the code in the core algorithm, as well as making sure that the voice rec functionality works. Moving on is a USB connection test bench. Jan and Shweta are spearheading that one. The problem is that we want to implement the controller chip of the Arduino, Arduino Uno, which is the ATmega 328P controller, on our actual board. So our board is going to be a unique board that's like never existed in the world before. It is way more compact, and it's actually a lot cheaper than buying Arduino boards that are already made. However, we're currently facing an issue of a USB serial connection issue. We're not able to connect our board to a computer to flash code and check system status through the USB. This is a significant problem because we won't be able to, like, a lot of people use USBs in order to make the connection. If they want to do customization towards the system, a USB connection would be fantastic. And so the goal would be to create a test bench just to focus on the USB connections. Functionality, as stated before, we want to check a few pin for functionality. We want to have the ATmega 328P controller, as well as the USB port. The current status is that, again, we need to add a reset switch for test bench to make the test bench like easier to use. We need to fix a few components. And finally, in mid-June, we should have already purchased the board and we'll be able to test it. Now for some fun stuff, moving parts, if you will. Electrical hardware is looking into DC motor and PID force control, led by Eddie and Cade. Wow, what is wrong with my presentation? This is I'm so sorry, guys. The current arm has no control over force output. This is one shortcoming towards servo motors. Yeah, I'm sorry, I was just looking at the time. This is one shortcoming of servo motors. Servo motors are only allows us to control its position. but we cannot control the force. This leads to a huge issue that you would use the same amount of force no matter what you're holding. And you can imagine that if you're using the force required to hold up, your groceries, to, to hold a paper cup to drink water, you're gonna crush that paper cup, and that is pretty bad. So the goal is to create a proof of concepts for some sort of analog force control, varying degrees of force being outputted from the system. In order to do that, we're looking at the bare direct current motors, just bare DC motors. The current status is the schematic is complete. We need to test some sort of power issue that our current system is facing. And then we're going to design and create a test bench in order to actually prove that our PID force controller would work, i.e. we can actually output analog force control quickly and effectively using the Arduino. And yes, we would very much likely would need some help from software in implementing the core algorithm, this algorithm in mid-July. Now, in order to determine like how much force is actually being implemented by the DC motor, we need some sort of sensor. And we have decided to put these sensors at the fingertips, as these, we usually touch things with our fingertips. So the problem is, in order for PID control to work, the system needs to know the forces at the fingertips. And the solution to that is to put sensors in the fingertips. We're currently thinking of using infrared sensor to detect the deflection of the fingertips. The current design, and I think mechanical team will talk more about like how the design process would look like. In terms of electrical, we would be doing this test bench to determine the relationship between deflection and force. So deflection will be read into the system as some kind of number. It's going to be like maybe like 0 if there's no deflection, and 1,000 if it's like maximum deflection. We need to know what that relationship is. The test bench has been tested by yours truly, Cade and Eason. Had a great time there. And then by the end of June, we should be able to find the relationship between deflection and force of a new fingertip design. I think that is, oh, well, last one. We're also looking at different sensors with collaboration with the interface team. We're looking at capacitive sensors. So this is like, just pointing out, Rennie will talk way more in depth about that. Some other types of sensors that we're looking into includes of just using some sort of mechanical sensor, something that instead of detecting electrical charges in the body, we're just looking at the physical deflection of your muscles while you flex your muscles. The problem of electrical, sensors looking at electrical signals is that they're kind of expensive. And just going back to the price cut of things, if all the electrical components is $100, our sensors is like 40. So that's like 40% of all electrical stuff. That's not hot. So in order to try to deal with that issue, we're looking into different sensors. And one of the cheaper ways was going back to a document that Max has sent to me. This is some kind of, this is a resistor that changes its resistance based on the applied force. I tried doing this one summer and then I failed because I didn't read the research paper. Now that we figured out why I failed, Ratika will be spearheading this investigation towards cutting the cost of detecting muscle peaks. Right. The status is that initial CAD models have been completed. It will be checked in the upcoming week in order to determine whether it's like usable or not. And then we're going to print the parts, ship the parts out to the members who are working on this project. And hopefully we can create a very, very steady relationship between muscle peaks and signal output. again, very sorry that we can't really go very in depth towards like what all the electrical stuff are. If you are interested towards gaining the basics of what electrical team does and what we deal with, feel free to check out these links. I've placed the 3 boot camp sessions that we usually have over the fall and winter semester while we train new members, as well as an Arduino basics folder, providing many Arduino mini labs, if you will. Each takes about 5 to 10 minutes, and a Arduino booklet, which is Arduino's official guide towards how to use your system. Now, thank you for your time and your patience. Are there any questions? Yeah, that is the end of, yeah.
Yeah, any questions about the day-to-day or what specific modules you might have questions on, or anything else revolving around how they work with other teams? If anyone has any questions.
I just had a quick question. When you were talking about like the dial or voice control to switch between the different states of the arm, what exactly are the different states of the arm?
Currently we have 2 motors. That's a good question. So the question was, what are the different states of the arm? Yeah, Grant? Yeah, so currently our hand is controlled by 2 motors, and one motor will control the thumb and the index. So it would extend and flex like that. The other motor will control these 3 fingers. So the middle ring and the pinky. What the states do is it controls which motors are being actuated at what point. So I believe we have a state of just pinching like this. We have a state of doing this kind of motion, of a pointing motion. We have states of like fully closed, fully open. And I believe we have like an alternation state. All these states, and this is like a huge software like code revamp. They're trying to make these states user definable. So any person will be able to customize whatever state they want. Mm-hmm.
Anything else? Anyone has any questions on as we wrap up?
I have a question. For the voice rec, is that calibrated to the individual's voice or someone else's voice?
That's a good question. So the question was, is voice recognition functionality for it's from like a universal voice, or is it from a specific person's voice? Aha. We want it to be,
yeah.
Yeah, I think we want it to be like a specific person's voice. However, I don't believe our current voice recognition module allows for that. And so I could speak in, for example, Yusra, your voice to control your arm, and your arm would think that I'm Yusra. So that is one shortcoming of our current design.
Yeah, some bugs are being fixed, and we'll get into more of that in software. But essentially, yeah, you'll be able to dynamically change the voice commands at will. But yeah, sweet. And Electro, when are your meetings?
Our meetings are workshop-based meetings where people just come in and they do work. So our meetings are usually Saturdays from 2:30 to 4 p.m.
Awesome. And outreach. I forgot to ask you the same question just because we were running a little low. So when are your meetings?
We're planning on having our meetings, I believe, on Fridays, sometime in the afternoon. It still hasn't been defined yet, but we'll reach out to everyone who's interested and let you guys know.
Awesome. Sweet. Thank you, Electrical. Let's move over to Grant and Charlie for Mechanical.
All right, Grant, you want to get us started?
Yeah. Hey guys. So for you guys that don't know, I'm Grant and Charlie's the other person. We're co-leads on the mechanical sub team, and we're just gonna be talking about like what we've done this past semester, and then kind of what we're looking to do in the future, and then just kind of like what the whole team's about. So what we do is a lot of like R&D, working with the electrical team, and then also the team that's getting the measurements to make sure the arm's going to fit our patient. So Michael in this case, and then also just making sure all the new electrical components can fit into the arm, like the motors and all the sensors and stuff. So now I'm just going to talk a little bit like what we've done in the last semester. The first thing we did is we created a new hard stop for the elbow joint. It's modeled after this range of motion brace that people usually get after surgery. So it's similar to like an elbow brace or a knee brace. So basically that works by the doctor will assign like an angle that the person's arm can bend to, and then it just kind of stops there. So we did a little bit of research on that to figure out how it worked, and then moved from like an external hard stop that we had previously to more like one that's kind of streamlined and internal, that you can kind of see there on the left. So initially we had it like about 180-degree angle, so like full extension of the arm. And then since then we've moved it in just a little bit, I believe, because Daniel brought up a good point that like 180 is not exactly like a natural angle for an arm to go at. So it's just slightly less than that. And then we also had a couple of people on the mechanical team looking into potential actuation methods, just so for like the fingers to close, maybe different directions to go from where we are now. This kind of ended up hitting a wall, but like one of the ones we were mainly looking into was pneumonic actuation, which uses compressed air or like a type of gas, and essentially just kind of gets like a reading and then will almost like inflate like muscle kind of material, and then allow the hand to move, like the fingers to close and stuff like that. So we were gonna have to change like a lot of stuff for this, and then I think we ran into an issue where it's going to be kind of expensive to find this, as well as changing the material up. So we kind of moved away from this and focused our efforts elsewhere. And then we also had a couple of finger issues just when we scaled up the model for Michael's new measurements. We were having a couple of issues like when printing the model. I think there was some finger fusion, just like the parts were getting stuck together and there wasn't like full range of motion of the finger, so it couldn't move quite properly. So we had a couple of people just go in there and make a couple of edits. So the finger's all good now. And I think we actually might have done a new design for the finger. And I think it looks pretty good.
All right, so now I'll talk about what we're kind of working on now. So first off is a wrist redesign. This on the left, the two pictures are what the wrist looks like now, and we're having problems with the printing process and with Michael being a young boy who obviously likes to be active and kind of isn't super careful necessarily with the arm, so was prone to breaking at the wrist. So we have a group of people working on redesigning that, and they're working on implementing the PVC adapter you see on the right. This will then we'll have to epoxy it to each side of the hand and the wrist and the forearm, my bad. And then the hand will screw on to the forearm, and they're going to implement some sort of pin going through the PVC so that the wrist doesn't come loose and fall off. But this should allow the wrist to be stronger and easier to assemble and easier to take off, as we're looking towards creating different hand attachments in the future, so that depending on the task that the client needs done, different hands will be better at performing different tasks. So for example, like video games, we could design a hand that has better movement and doesn't necessarily need as much force, but more precise movements, and things like that moving forward. We also have a group working with electrical, doing light aesthetics. So to make the arm look kind of better and have the children enjoy the looks of the arm. We have a group creating a shell that goes around the different parts of the arm, including the palm and the forearm, and then eventually the tricep cuff as well. And originally we were going to use EL wire tape to put lights on that, but due to expense and stuff, we're now looking more towards LED lights. And kind of the thought process behind this is creating something like you see on the right, which would be like the Infinity Gauntlet, so that the arm looks better. And then moving forward, we'll have to probably edit the forearm so that the shell can clip on over the current forearm. And so then it would be easy to take it on and off if he doesn't want it on for a while, or if he does, just provides them with more options. We also have a group working on finger sensors with mechanical or with electrical, my bad. So this is the sensor, is the tip and the clear part that you can see on the left. And then the sensor would allow us to be able to tell the force needed, and then moving forward, that would work with what electrical is doing and creating a force that can be variant essentially. So for different tasks, it can do different things. And this is kind of a new finger design on the right as well for a different actuation, so that the stringing doesn't have to go all the way through the finger. So that's another thing that is kind of piggybacking on that and trying to prototype those. And on this slide, you can see the printed prototype on the right, and then also another finger design on the left that is also printed on the right, so that it's with a more flexible material that wouldn't need the joints necessarily, but instead could just flex. So those are things that we're looking at kind of changing about the fingers. And then the tools commonly used essentially is Fusion 360. That's what we do all of our designing in, all of the print files come from there. So I'm actually going to switch over to Fusion. All right, so can you guys see Fusion now? So we're just going to go through kind of the different aspects of the arm and what they look like on here. So this is actually the arm from last year because it's been completely finished, and so I figured it'd be easier to go through that one. This is the tricep cuff and the tricep socket where his arm goes in. Since it has been redesigned with the hard stop, it looks a little bit different, but this is what the one was that we built for him last year. It's just Chicago screws going in on the sides so that it can bend and rotate. It was kind of heavy, which is why also in the redesign it looks a little bit thinner and a little bit nicer, I would say. So those were created separately and then just put them in assembly together. And then we have the forearm, which is kind of a monster. This is what it looks like, and then we can hide certain aspects of it. So I'll hide the lid. And you can see inside it gets a little bit crammed. Here's our two motors, and then the battery, and then here's the PCB Daniel was talking about earlier. So all of that gets modeled, all of the electrical components get modeled and into files so that we can make sure that they fit within the arms well. You can see it's a little bit complicated stringing because the motors need space for the string to go around and through this area on the wrist. So it can get a little bit complicated fitting everything within the forearm. And next we have the hand. So this is the assembled hand. We created each part individually and then assembled them together. You can see the thumb, how it looks a little bit different. That's just for a different range of motion. And then rivets go in, pin joints go in on each finger so that they can rotate around that as well. And what's cool about Fusion is and CAD in general, is it's generally starting from nothing and kind of building from there. But with Fusion, you can also like import different kind of shapes and stuff and build on those and create those, which is really nice for the different kind of weird shapes and stuff on the hands and stuff to making it look like a real hand and not super blocky and stuff. So then lastly, we have the full arm, which I just think it looks really professional and cool. So yeah, that's kind of Fusion. Fusion's also really nice because you don't have to save individual files like on your computer, but instead can use them each. So I can use this on my computer and save it, and then Grant can go on his computer and they'll see the same version I have. Cloud sharing like that. Yeah, if you have any other questions about CAD or want to learn more, definitely reach out to us. It's a very powerful tool and it's it's what mechanical does the most, I would say. And helping electrical or manufacturing if they have any CAD issues or stuff like that. So yeah, any questions?
So what does the typical day look like for meetings as far as what you have scheduled for tasks for individual members?
Yeah, so during the summer, we cut our meetings back to every other week on Monday nights. But during the school year, it would be every week. And we kind of go through getting to know each other with the icebreaker and stuff, and then moving to updates from the teams and discussion if they have any questions about where they should go or if this will work and stuff like that. And that's something we're trying to encourage more moving forward as well, so that the meetings can be as productive as possible. And then we kind of move into odd things like stuff that came up throughout the week and where we kind of move forward with those. And then we usually try to add a tutorial to the minutes that people can do on their own time generally, and try to get better at CAD. And then, yeah, that's pretty much our meeting structure.
Sounds great. Any other questions about working with other teams? I know you highlighted that, but anything else anyone has been wondering about?
What do you say would be some like important skills that a member would come out of through joining and experiencing a mechanical team?
I think definitely a lot of our members, obviously we kind of try to look with people that have like a little bit of a CAD background, but sometimes we'll even take people that haven't used CAD in the past. So when they come out, then a lot of the time they're like significantly better at CAD and specifically Fusion 360, as well as working with people because we usually like switch them around in groups. And then when we kind of move on to new projects, we kind of move the teams around. So they're like get used to kind of adjusting their schedules and then delegating the work to and like splitting it up between each other and stuff. So.
Cool. Anything else while we have you here?
So for the finger redesign, is that just like an option for the future, or are all arms going to have a redesigned finger?
It's more of an option. We still have to figure out exactly as we finish this build what we're going to include in the next build, and seeing what works well on this build and what kind of needs to be redesigned. But the stringing of the fingers is always a big like headache, and especially as we move into trying to find a new actuation method, having a different designed finger will become more important. So doing some legwork right now on that moving forward.
I may have missed this from earlier, but did you mention when you're planning on looking at designing an elbow in the future? So working with people who have an amputation above the elbow?
We haven't placed a date or anything, but that's just something that we kind of thought would be a very good idea and very interesting. So I guess we'll have to discuss that as we look into what is going to be included on the next build. And if we want to create a version that has that, we definitely think it'd be cool. But
What would you say the hardest part of mechanical is?
I'd say there's a lot of like CAD is awesome and you can do almost anything with it, but figuring out how to do things can sometimes be a headache. So it's a lot of talking with other people, just trial and error and researching different things. I'd say that's the most difficult and kind of painstaking part, at least. But once you figure something out like that, then it's just really satisfying and kind of you feel like you accomplished something really cool. and then you know that for the future as well and how to do a new skill.
Yeah, I also think like Charlie was saying, like in CAD, you kind of start from nothing. So whenever we're designing like new components or new parts that we need, um, I think that's kind of a difficult part, like kind of finding the starting point and like getting the general shape down. And then after that, it kind of like becomes fun, I guess. And then everything kind of cleans up nicely.
And then how much of your development goes into figuring out what is 3D printable and what is not? Because per se, in the arm, in the forearm specifically, there's like some cantilevers or hanging beams and things like that. So how much of that goes into, okay, well, we designed it, but can we actually make it?
Yeah, I definitely don't have a 3D printing background. So even moving forward, definitely will need to speak with manufacturing and make sure things are printable. But Allison in the past was really good at kind of seeing, like she knew about 3D printing and knowing what could be printed and what couldn't. So adding like fillet stall corners and stuff and making sure that you have somewhere to build off of from the print orientation just becomes really important. But I would say generally it's pretty easy to make the minor adjustments if manufacturing does say that something is not printable.
Sounds fantastic. Yeah, so we'll have to get a little bit more coordination between those two teams, of course, in the future, and with our upcoming workshop, getting a little bit more experience on what can and cannot be printed and how to do so, and settings to optimize based on that. Cool. Any additional questions for mechanical? I guess one question would be, and this ties into the assembly, is how do you select your screws and what you want for each? Because there's quite a variety. There's some socket-headed screws, there's some threaded heat inserts, and there's like various size nuts like M4s that you use. So how do you go into selecting all that and what's best for assembly in essence?
Yeah, so it's a lot about the function of what the screw has to be able to do. Like for example, in the tricep cuff, it needs to be able to rotate, the joint does. So we use a Chicago screw there where, I don't know if I have a picture of it anywhere, but basically one end is a normal screw and the other end is a screw that has the threaded inside. And then the outside of that is smooth. So it can rotate about that easily. But then, for example, like if we're screwing on the lid, it needs to be tight and not fall off. So using a different type of screw there. And then also figuring out like distances and what type of strength is needed. So in Fusion, you can do animations and stuff and kind of test things to see how much force is required to, for example, like hold up the arm and stuff to make sure that things won't break. So doing things like that and making sure that a screw is able to withhold that amount of force.
Sounds great. And you said your meetings are bi-weekly. So what time are those currently?
Yeah, so in the summer, we're doing them bi-weekly, Monday nights from 8 to 9. And then we'll send out another one to meet in the fall, and those will turn back to weekly meetings.
Fantastic. Thank you, Mechanical. I guess we can pass it off to your interfaces. So Rennie, if you want to take over.
Share my screen. Can you see it?
Yep.
All right, so I'm Rennie. I'm the lead of interfaces, and interfaces is primarily a research team. A lot of what we do is just research and testing for right now. So the goals are to develop wearable sensors, be able to present our research, and the sensors is our collab project with electrical. We want to make sure that the sensors are cost effective and efficient so that we can use them for future builds. And we want to develop a build with better grip, and we're either going to do this by using better finger grips or using soft robotics to create a hand that has better grip and flexibility. So this is our current design that electrical has. So
we place the surface electrodes. So there's 2 on the belly of the bicep and then 1 ground. And as you can see, the sleeve is basically just a compression sleeve with holes cut out where the electrodes are. And then the finger grips, which aren't fully great right now, we just put them onto the fingers, and we're thinking of putting some resin or something on them to make them more grippy. And we thread a conductive thread through the finger grips so that we can have like iPhone compatibility and stuff like that. So our current projects that we're working on are boot camps. So we're doing sensors, and for that we're in testing and design right now. Finger grips, which we're in testing and research, and soft robotics, which we're just in research for. So for these boot camps, we're having 3 of them. 2 of them are complete. The design process, which is hosted by Interfaces, that's been complete. The Arduino, which is complete, and the sensors and signals, which was supposed to be yesterday, but we had to reschedule. So look out for a message in Slack about that. So this is the electrical and interfaces collab, as I said. And we just want members to know more about the components and more about what they're doing. Because I know Interfaces members haven't had a lot of experience with Arduino, and I do want to get them to know the design process more so that they're able to communicate with each other and give each other ideas, which is a big part of research. Yeah, so now if you want to check out the recordings and PowerPoints, they're in the interfaces folders under boot camps. And we'll send a message about the sensors and signals one. So the current sensors that we have tested or are working on right now are the capacitive sensors, which involve the copper electrode, fabric electrode, and flex print electrode, and then the jank sleeve and a strain gauge. But the strain gauge is on hold for now due to some people couldn't participate in right now. So for the capacitive sensors, basically they use the same filter circuit, but with different electrodes. So obviously like one will be a copper, the flex print and all that. And what our members are doing currently, Sue, Eli, and Daniel are working on these. And so they're developing and testing the electrodes, and then they're gonna try to make them more wearable. The boards have already been developed thanks to electrical, and we've sent them out. So now they're just going through the boot camps, and then we'll have a meeting about once a month to discuss what they have found, where they'll present their findings. So if you're interested in attending that, please just let me know.
Uh-oh. Oh, there we go.
Okay. I guess the picture didn't load, but I'll just escape for that. So next we have the electrostatic force sensor, which is already developed, and the documentation is there. I can send it to anybody who's interested. So Interfaces, Alex is currently working on this, and he's trying to make it into a wearable sleeve. So basically this is what the sleeve looks like, right? I think I have a picture, I'll show it after. But yeah, so the sleeve is basically just fabric right now with a few wires sticking out. So Alex is trying to make that more wearable since we found that electrical has developed it thanks to them. And we're just, the signal and everything works. We're just trying to make it wearable and not have any signal interference with that. So next, the thing we're working on is finger grips. So we want to improve it from our current finger grips, which you saw on the first slide. So the types that Rebecca's looked into are finger cots and finger rings. So as you can see, the finger rings are on the left and the finger cots on the right. We're not really sure about the grip of them. We're going to order them and test them out. And we're thinking of putting some coating on them to make the grip better and for better flexibility and stuff like that. But yeah, we're going into testing for that. And then next is soft robotics. So we're looking to improve grip and flexibility and to develop a hand from soft robotics. So Raj is currently working on this. And as you can see on the hand, these are both hands using soft robotics. I think the one on the left is from the University of Melbourne. And they use specific 3D printing techniques, but it was kind of expensive. So we're looking to cut down on that by reading those research papers and seeing how we can make it cheaper and if there's any other way we could use. And then the one on the right, I believe uses TPU A90 filament for 3D printing. And yeah, that's just, it's not that it's expensive, you just need a specific 3D printer for that. So looking into that, we're seeing if that's one of the options that we could use, or just basic other 3D printing methods. And I think that's it for interfaces. We don't really have much right now because we're a research team, but yeah, we're currently working on testing, research, and development. So any questions?
Yeah, I have a
Yeah.
question. I'm sorry if I
Okay.
missed it earlier, but could you explain again the difference between a hand made from soft robotics and what we have now?
So soft robotics, it offers more flexibility. So as you can see, when they use like different 3D printing techniques, I'm pretty sure that it's more like the grip increases as well, because right now it's just kind of goes together. But soft robotic, it feels more like an actual like hand where you could like move it like that. If that makes any sense.
Yeah, it can also deform to the shape to better equip it, whereas our current figures kind of are hard lock. So if it wanted to grab a ball, it can't really like fit to that, but soft robotics can.
I have a question. Is there a reason that or I guess more so, is there a different type of TPU that is more common that can be 3D printed on the printers we have?
I'm not sure. Well, the person who's looking into this right now, I talked to him and he said that there does need to be a specific printer, but I'll ask him to look into that if there is possible, because it says it needs, yeah, it's TPU 90, which it says it does need a specific, the flash force guider too. But
Yeah, just because I don't know about like that high of a grade of TPU, but I know that some TPU can be printed on regular 3D printers, but I don't know if there's a similar, I assume TPU 90 is super flexible. So that'd be my guess why, yeah, but it might be worth something to look into, is maybe there might be a different type of TPU.
yeah, I'll definitely discuss it. Thank you.
And then when are your meetings, Renee?
For right now, during the summer, we're having our meetings Thursdays from about 7 to 8 or 8 to 9. If you want to know more, you just join the interfaces chat, because those might change depending on people's availability. But yeah, in the fall, we'll send out a when to meet to decide weekly meetings, because right now they're bi-weekly.
Any other questions, guys? There's no question not worth asking.
I guess how would you better work with, or what could other teams understand about you more? Because out of all the teams, people were least familiar with interfaces, especially given, of course, that it has gone through a new name change and gone through a bit of a difference in what it aimed to do initially. It was initially materials and did materials testing, and now it's interfaces. So other than electrical, how do you plan on working with the other teams in the future, per se mechanical?
Yeah, I think since we're still new as well, like the team and everything, the name, I think we're still working on our goals. But with mechanical, I know they were working on grip and things like that. So maybe working with them with soft robotics in the future, once we develop farther than research, because we already reached out to them before, but we found out what they were doing was kind of different from what we were looking at. But now it's kind of similar. So just reaching out to teams like mechanical and manufacturing to 3D print stuff, things like that.
Fantastic. Yeah. Also, apologies there. I don't know if the meeting got interrupted. I hope it continued. Awesome. All right. Yeah, my phone just died there, but we're all good. I guess another question for interfaces is, I guess, are there any additional projects that you plan on pursuing, or how do you generally have members work on projects? For those who are not aware.
Yeah, for right now, everybody pretty much takes their own project. So for the sensors, everybody's working on a type of sensor, or somebody is working on finger grips. Everybody has one role and like the head of that role, basically. So for the future, basically we're just talking about things that we want to do and things that everybody on the team is interested in. And we're going to try to make some new projects new research projects we're looking to the fall for new members. So right now, I think one of the things we're looking at is sleeve technology and temperature control and a bunch of that, and seeing if it's possible to make it cost efficient and things like that. So we'll probably look into that more in the fall, and then just discussing with new members to discuss what they're interested in and see if we can incorporate that in any way.
Any additional questions? I know you have some because, as said, most people wanted to know the most about interfaces in that team leads poll.
Yeah, I don't know if you want to ask me any private questions, I could probably answer them. So you could just message me on Slack if there's anything after you want to ask.
I'm kind of interested in the software. Oh, sorry.
Oh no, you can go ahead, Daniel. Go ahead. Sorry.
I was kind of interested in the soft robotics development. What's the status on that? Like what do we know about it, and what can we test about it?
Yeah, it's very early right now. We just started it maybe 2 weeks ago, and it's just been somebody researching it. So when we have our meeting on Thursday, he's going to present whatever he has, and he has a document with all the different, he read a bunch of research studies that Max sent us, and he looked into a few more, and he just has a document discussing what we can do as interfaces that's cost efficient, and we don't have to, that are better alternatives than you buying a new printer that can use the TPU 90A. But yeah, so right now it's really early. We haven't really done much with it, just research.
To echo that, I'm also really interested in the soft robotic stuff, so maybe I'll come to the meeting.
Yeah, next Thursday we're gonna be talking about it. It's only a 30-minute meeting, so feel free to stop by real quick.
Yeah, and in the future, just for everyone as well, I would like to have these kinds of meetings every month at the start of the month. This is of course on the 30th, but close enough, so that we can get to know a little bit more about each sub team. So not necessarily just an introduction to everything, but more this kind of thing, specific things that people might be interested in each sub team, that kind of situation. But before we do that, any additional questions about, per se, things outside of just soft robotics, how they plan on gripping things more, or otherwise things that you as your sub team would be interested in helping out with?
Imagining with soft robotics, there's going to be coming new actuation schemes and like new electrical components involved. So in the future, if interface team has like found the documentation for testing electrical, would be happy to help out.
Yeah, definitely. Thank you.
And I'll definitely say for mechanic or manufacturing and TPU is a very fun filament to print. So I think it'd be a good experience for my team to learn how to use it. If you guys can figure out one that is a little bit more available to general printers. I'm really dumb and I don't remember what the flexibility was that we used, but I'm sure it's out there.
All right, thank you. I'll definitely tell Raj to reach out to you with any 3D printing questions.
Also, side note, not technically related, but I found a flash sale of PETG, and it's $10. So if anyone wants some, we're going to be ordering a bunch of things Monday. So get them while they're hot. White, gray, and black filament, all $10. If anyone wants an arm for themselves, let's do it.
Just one comment on, sorry, the soft robotics thing is very interesting. Sorry, I keep talking about it. One thing, is it possible to, instead of printing it, but molding it instead? So like currently, electrical team has been creating new fingertips using silicone. We create molds for the silicone using, just PLA, which is pretty cheap and pretty manageable.
Yeah, it's definitely possible because some of the research studies definitely, like, they don't even use 3D printing. And Raj said that was one of the options that he was considering. So yeah, I'll definitely let you know in the future if we're planning. Well, we'll test it, all of them probably, but yeah, I'll definitely let everybody know whatever we're doing with the soft robotics when we finally get to development.
Yeah, I think that having a soft material would be totally in demand from the SAMS patients. So I don't know how far you guys are in. I know you mentioned it's still very baseline right now, but in the future, I think there'd be a huge demand for that based on my conversations with them. So really interesting.
Yeah, I think right now we're still in research, but hopefully by the summer we'll get to testing. And then maybe next summer, probably development or something like that.
Fantastic. Yeah. Also, Rex, is it okay if I share your question?
Yeah, go for it. I just didn't want to interrupt.
Oh, no, you're fine. Yeah. I guess actually before I do that, any other questions about interfaces in general? Or kind of plans for the future? Anything else? Soft robotics is a big hit. So I actually would like in one of the future all hands meetings to dedicate a little bit more time to that outside of the kind of start of the month. So if that's fine with you, Rennie.
Yeah, that's all good with me.
Awesome. But yeah, a question that I encounter myself and I've been waiting through is if anyone wants one of these hands themselves and wants to, whether that be for testing or anything else, I think that we are at a capacity right now to where we can print these arms pretty quickly, pretty easily. I've printed 2 as of now and just have to assemble them, but have all the components necessary to do so. And since we're doing a workshop next week where we'll be doing just that thing, if anyone wants them for testing or personal use, please feel free to reach out. If it is just for personal use, I would say that you probably do want to order the filament yourself. I can send links for that. A kilogram is all you need for the entire arm. But I know that interfaces could definitely benefit from that. Mechanical for sure, electrical and software, absolutely. And outreach for showing to people. So if you want an arm, I'm gonna post a poll, or not a poll, but just to, form if you're interested. But yeah, thank you, interfaces. When are your meetings? I believe they're bi-weekly as well, right? Or you said monthly?
The summer is bi-weekly, every Thursday, 7 to 8 or 8 to 9. Join the interfaces chat if there's might be any updates for that.
Fantastic. Thank you for sharing. Now I will send it off to Simi and Rex. So Simi, you probably have the presentation open, yes? Cool.
Yep, let me pull it up. Okay. Hi, everyone. I'm Simi. I'm the software co-lead, and Rex is also a co-lead. So we're going to talk a little bit about what software does. So the 2 areas of software, I would say you could divide it into algorithm and application development. So primarily in the past and also in the current and moving into the future, it has been mainly focused on improving the algorithm for the prosthetic and expanding on what it's capable of doing and how efficient our algorithm is. And so an example of one of the future projects that we're currently working on and hope to continue to work on in collaboration with electrical is the voice recognition. So this would involve creating that code and then integrating it into the main algorithm and making sure that it runs smoothly. And Rex can also talk about this a little bit more. As for application development, that's kind of like my area of expertise, I would say. So we're currently working on the development of a Bluetooth app and also a touchscreen interface for the prosthetic arm. And it's kind of like the user can choose which one best suits their needs. So you might be wondering, an app, like why would you need an app if we're like a team building prosthetic arms? And so the purpose for a Bluetooth app would be to allow the arm to connect to an external device and allow for additional functionality that might be difficult to do on the arm itself. So examples of potential functionality that we want to incorporate into our app would be data analytics. So things like tracking what are the most common state changes that the user uses. It's battery life, it's performance essentially, parameters. So one of the biggest parameters that our algorithm is based on is the threshold. So since it's based on electrodes in the myoelectric sensor, it's important to know like what that minimum threshold is at to allow for different state changes. So as Daniel mentioned previously in his presentation, we're kind of moving more into a user-defined state change, allowing the user to customize what they want those parameters to be set as. And so that's something we want to do in the app for ease of access. Another cool thing that kind of shows the possibilities of what this app could do is incorporating some sort of air mouse functionality. So this again would be in collaboration with electrical, but basically what the app would do is allow the user to activate the arm to be used as an air mouse. And an air mouse is instead of like your wireless mouse that you have to manually control on like a flat surface, an air mouse would be able to do it in the air and sense those movements. And the last one is so much more. So there's really, the possibilities are endless with a Bluetooth app. Oh, is there something in the chat?
That was just me. I was just saying it basically it's a Wiimote, but yeah,
Okay.
Continue, sorry.
No, you're good. So something that we're kind of currently working on in terms of the Bluetooth app is UI and UX design, which is short for user interface design and user experience. And so these terms can kind of get thrown around interchangeably, but they are pretty distinct things. So it can be important to know the difference between them. So UI is what the user interacts with. So that could be like buttons, that could be layout, navigation, a home screen, things that you visually see and interact with in an app or a website. UX design is the user's experience and how they feel about those interactions. And so this could be positive, negative, or neutral. And ideally with our app, we want the user experience to be as positive and as efficient as possible for the user. So this could involve wireframing, prototyping, and a lot of user testing. So here are some examples to kind of like, I guess, emphasize the distinction. So you can kind of see in the left where it's like a little like nursery thing with a bunch of animals, and the family kind of thinks it's like, oh, it's so pretty, it's cool, but the child cannot really see the animals, so they're not really benefiting from it. And in this case, the baby is like the primary user. So that's an example of bad user experience. Another one, so this is a pretty common example, I think, for UI and UX, where it's like the one on the left, like, although it looks really nice and like kind of sleek and minimal, like it's not nice in theory and you're not able to like get any ketchup out of it. And then this last one, I think this is hilarious. And it's basically like you design like these really nice sidewalks, but then like the actual user experience ends up being like taking a shortcut. So keeping in mind the user when designing. So our current wireframe, a wireframe is essentially like a skeleton of what the app would be like. So there's no development in this. This was made using Adobe XD. And so you can kind of see a few of the features that we tried to emphasize, such as like a clear logo, a very accessible menu on all pages, buttons in the center that allow you to access all the different functionality. So things like I mentioned in the past, data analytics, or being able to update the arm in like a control center. And so our current prototype, this is where development comes in. So we have been using Visual Studio to develop, and this has allowed us to make our app cross-platform. So not only making an iOS app, but also one that works for Android. So some of our features here that we've developed so far include a homepage, buttons that have individual pages, and a little menu bar at the bottom. And currently this is able to run on an Android emulator, which is essentially simulating what an Android device would be, but it's like simulating it on your laptop. And it still needs a lot of work. We're in the very early stages of app development, but hopefully in the next 2 semesters, we can get a solid working prototype. And so one of the other projects that we're working on with electrical is the touchscreen interface. And Rex can also talk about this a little bit more as well. But the purpose of this would be that the user can choose between a touchscreen and an app as to what they want to interact with the arm. And one of the benefits of this is that some people don't have smartphones, and also smartphones aren't easily accessible in different parts of the world. So when we're expanding our audience to international and to different countries, it's important to kind of think about accessibility in that way. And so our progress so far is that we currently have a schematic for the hardware part of it, but we're working on creating an interface for the touchscreen itself and getting it to work. I think we're at like a standstill right now, but we'll get there.
Yeah, and the other benefit is it saves the hassle of having to pull the smartphone out and then use it, which seems like not that big of a deal, but it's actually quite a problem when you already like have one less fully functional arm.
Mm-hmm. So some things that we are kind of considering in terms of the user interface and user experience are accessibility, usefulness, and feasibility. And these 3 things have kind of made us take a step back and approach it, I guess, again, from a different perspective. So in terms of accessibility, like, is our app easy to navigate and most accessible for as many people as possible? Since our audience isn't, we have to consider like a broad audience and not just our team as the audience. Usefulness, is our app something that the user would find important, or is it something that us as developers would find more important? So are we adding functionality that the user would find like unnecessary and would never touch, or is it something that they'd be like, wow, this is really important and something I use every day? And in terms of feasibility, is this something that we are able to develop with our current resources, or do we need to branch out and kind of expand our resource base? So things like, do we need a database for example, data analytics? Do we need a place to store that data? And how are we going to do that? That would go into the feasibility category. And so some of our summer goals for specifically on the application side of things is I divided it up into 3 things: research, design, and development. So our the next step that we're taking that's coming up soon is to meet with an industry UX designer. And she actually works for IBM, I believe, as a UX designer. And so we're going to essentially discuss how UX works in industry and how we can apply this to our app and improve our user experience and what questions we need to be considering. As for design, kind of taking the what we learned from that conversation and modifying our current mockup and reflecting that in the prototype eventually. And as for development, I think a great summer goal would be to finish the UI in the app so we can move into the functionality and kind of the cool stuff that the app can really do. And as for like semester goals for the upcoming school year, with the Bluetooth app, have a working prototype and potentially start conducting user testing, hopefully in the winter, in early winter. I think that that would be really useful to get user feedback and make additional modifications based on that. And for touchscreen interface, adapting our app UI to work for the touchscreen and getting it to work. And as for other, we're very open to suggestions. We're a relatively small team, and so we're always open to new ideas. And as for ideas, it could be either on the application side of things or the algorithm side of things. There's a lot of ways that software could be used. So yeah, that's it.
Yeah, and I should add on there. The smaller side of things is the UI. So if anyone in outreach is interested in actually working on that, that'd be fantastic. So
Yeah, for sure. Some comments from me. That was probably the most aesthetically pleasing presentation I've seen in a while. Thank you, Simi.
Thank you.
Yeah, and I feel like we very casually ran over the pizza button. Can someone explain, please?
okay, so oh God, should I?
Go for it.
All right, so I'm, as we all know, a bit of a crackhead, and so not in a reality, I should clarify, but you could confuse me for one. And so essentially as a proof of concept, it was in essence intended to be using something called if this and that, which is an application, and it's just a very, very easy way of connecting your phone to an external device such as Arduino and having like a program protocol. And so what it would do is essentially every time you slapped a button, it would go through the Arduino and order pizza for you. And so of course this was not going to be in the final design. That, you know, that is power unto a god, to be able to order pizza at any time you want as a 13-year-old child. And so I don't think that I would, in good faith, will that onto any child. But that's what it essentially was. And so we're probably not actually going to put that in the final design, but it was there in prototyping. I guess before we also go further into questions, anything else that you wanted to add, Rex, as far as goals, given that you more recently have been added officially onto the roster of team leads?
Yeah, very recently indeed.
Very recently, yes.
Yeah. So yeah, currently the biggest goal is definitely figuring out how to integrate the voice recognition module, like so that, you know, the user can use it seamlessly without having to use another third-party software to set it up first, as well as having to like unplug it and plug it with another adapter to save the voice commands. And hopefully we can get that done like over or in a few weeks, or at least like before August, I hope. And I guess the other thing is maybe once the other like sensors are developed and are available for testing from interfaces, we can see if we can calibrate them to work well. That's kind of what I'm thinking of.
Fantastic, yeah. Yeah, I should also add, yeah, basically the algorithm side of software will primarily be working with improving that using additional digital signal processing methods, and with whatever we end up going forward as far as the control scheme, implementing that on the back end. But yeah, any kind of questions for software, how it works, generally what the day-to-day is as with all the other groups, or any questions about how it interacts with the other teams? or things you're just generally curious about, I suppose.
Yeah, I have a few questions. First of all, like what language do you guys program in? Is it C++ or?
Yeah, for Arduino is basically C++.
Nice, okay. And then like how does that interface with Arduino?
Like, oh, Arduino has its own like IDE, like, and it compiles for the board.
Oh, got you.
Yeah.
Okay. Okay. Because isn't like the Arduino language like different than C++ or whatever?
It's
Or it's similar?
essentially the same with, like, you can think of it as basically the same with a few like add-ons.
Cool. And I was wondering like if I'm not on campus or whatever, and do you guys like have virtual meetings or?
Oh yeah, like I think both the software and hardware, so electrical team, we have
Nice.
meetings every Saturday on at 2:30 to 4. So generally we start with like, hey, what did everyone do in the past week, and then we kind of just split off into breakout rooms and like work on stuff.
Awesome.
I guess, yeah, any questions from people who might not be as familiar with coding? And I know some people aren't engineering and aren't otherwise forced to take engineering 101 or 151 in that case, or the analog of EECS 183. So any kind of questions about what goes down with the algorithm development or how that ends up working out? If not, I have a question for you, Rex.
Yeah.
So let's say I'm a 12-year-old and I wanted to make my own program. How would I go about doing that?
Ah, that's a great point. So right now we are also working on another project to like sort of, as I guess, build libraries. Like, so like you can think of it as like we make these like building blocks of like, common like functions that people would want to use when designing their own program. So let's say like, they don't have to go through the nitty-gritty of like figuring out how to set up the communication to talk to the arm. So literally when they want to build their own program, you can think of it as like our final goal being something similar to like Lego Mindstorms. So you just drag blocks of instructions and then you can chain them together and then like make your own fun program, and hopefully it doesn't hurt anyone. But yeah, think of it as like, instead of having to write code that looks like code, it's mostly just English. So like simple, it could be just like 5 lines. First line is like start communicating and then put the parentheses, and then next line is just like, oh, tell arm to spaz out or whatever. Yeah.
Researchers, yeah. Cool. Yeah, so meeting same time as electrical, 2:30 on Saturdays. Any final questions for any of the teams or in general as we've hit 2 o'clock?
So I'm interested in like going to I'm new to the club, by the way. I'm Ziad. Nice to meet you guys.
Same to you.
This seems like an awesome club. I think I'm interested in like interface and software. So is it possible to attend like both?
Absolutely. Many members are part of multiple teams. I would say that's fairly common across teams in general. I worked with outreach and software. Daniel is a part of mechanical and electrical. And I know various other members have worked across teams. Rex is software and hardware, for example. And then Catherine, you're manufacturing and materials, or sorry, interfaces, right?
Awesome.
I'm just manufacturing.
Oh, my bad, sorry. But also the financial director, so.
Okay. And is there like a schedule somewhere of the meeting times and stuff? I couldn't keep track of when everyone said.
That's all right, yeah. Yes, there is a schedule. I believe, are all members able to access the calendar? if people are aware. Okay, yeah. So you should be able to access the calendar, and I can add you to that. We have to add you to a few things generally. But yes, since you've been admitted, yes, or in the process of being admitted.
I have no idea.
Okay, cool. Yeah, so I guess for those sub teams, they'll probably conduct interviews after this. And if they're interested in having you, which I'm sure they would be, you can join whichever sub teams you so prefer to do so.
Awesome. Thank you.
Cool. Thank you everyone for attending. I will post this recording later, hopefully because it isn't on two devices, that doesn't cause a problem. If not, I will fix it. But thank you everyone for coming here. I will see you all next week where we will be doing the workshop, and I'll post that time very shortly after this because I did say that noon is the deadline. So we'll likely be 5 o'clock. Anyway, thank you everyone. I'll see you all later.
Thank you guys.
Yep, thank you.
Thank you.
Goodbye.